Plan for today. While other people finish folding that. Today we're not doing our textbook because we're going to do this flip book. I've got good news and medium news. I don't have any bad news. So at this point in the 9 weeks, your grade it actually has a long ways to go. So at the moment we have 3 60% grades in. We got to have 6 total. So that's only half of the 60% grades. So there's a lot of 60% grades happening in the next 2 weeks. Let's talk about that. Normally we do a math workshop test, but we've had so many people come in at different times, I just can't deal with that nightmare of like, did Mallory see any factoring problems or not? I don't know. So math workshops, they're great, and I swear to goodness we'll rock with them next 9 weeks, but there will be no math workshop tests this time. Just due to all the new people coming in at various times, I just can't. Okay, so there's 3 tests so far, or 3 60% grades. The 4th 60% grade is going to be the Chapter 4 test. It is going to happen next Tuesday. I already told you something important about that test. What did I tell you that was important about it? It is not a blank test. I said it was not a group test. So every group can have a point. It's a major number strip kind of day. It is not a group test, which is kind of scary because we've mostly done group things lately. So that's one thing. And so there is good news with that. There is good news. No, you're not going to have your group next, and it's not tomorrow, Tuesday. It's a week from tomorrow. No, you're not going to have your group. No, you're not going to get your book. But you are going to get this handy little thing. So this thing needs to be really important to you today. Go 3 words. Not just because, hey, that's what we're doing today, but also because you get to use this on your next test. So it needs to be useful to you. Okay. So our 4th thing coming up was the Chapter 4 test. The 5th assessment, or 60% grade this 9 weeks, is going to be Chapter 4 exercises. And that's what we're going to work on Thursday and Friday, and they'll meet Monday. Did you do some exercises? You know I'm going to do it like we've done in other chapters. If you have to do so many problems of the exercises, have you done it? Yay. And then the last final thing, which everyone should get 100 on, theoretically, is the semester exam study guide. Whether or not you're exempt from the exam, you're going to have to do the semester exam study guide. My plan is, if we test on Chapter 4 next Tuesday, that you work on the study guide on Wednesday. We go over part of the answers Thursday, part of the answers Friday. You show me you have it done, and I give you your 101 grade. Woo! It's not that deep. Are there any questions about that? No. So 2 of the 60% sound nice. The only 60% that doesn't sound nice is this test, but I'm telling you, you get to use this little book, so you can make it nice by making sure this booklet's important to you. Words. Okay, let's open to the first flap. The first flap is counting. I'm going to need your help on some problems, but today really is just a lot of me talking. I'm sorry for that in advance. So, what now? No, let me ramble and then you can have them. See how fast I can ramble. Okay, so the first flap says multiplication principle of counting. That's not what you and I have called it this whole time. We called it the fundamental counting principle. You and I did a lot of this in the last chapter, and it's come up a couple times this chapter. And what our goal is today is to know when to use this and when this isn't going to work. That's really what we're hoping to figure out with this booklet. Like, when do I use the fundamental counting principle? When do I use the formula for permutations? When do I use the formula for combinations? I just need to know when to use what, Miss Compton. I just can't figure that out. That's what today is supposed to help with. We've said this in the past, like on number 1. It says that they had 5 appetizers, 6 meals, 3 desserts, 2 drinks. So we literally would just multiply 5 times 6 times 3 times 2 and we would get our answer. What is our answer? Who said it? I heard it from them too. Every group can have a point. Okay, and those are pretty easy. Number 2 is just as easy. And that's what the instructions are saying at the top. Literally, P times Q times R, like our first option of the appetizers, our second option of the meals, our third option of the desserts, and we just multiply. So number 2, there are 7 colors for my headset. They can be noise canceling or not, so there are 2 options for that. And then there are 3 different cases. So 7 times 2 times 3, which is 42. 2 gets the point. And you're like, Miss Compton, that is so easy. Our last test was not near that easy. And you're right. I didn't pick this easy of a problem. It was a group test. Why would I put the super easy ones on there? I did the medium to hard ones where it's like, you know, we're still at a restaurant, but we need 2 different entrees. And so we had to like consider some extra stuff. I did make it a little extra on the last test because it was a group test. Okay, so still on that same flat, we get to number 3. I need to know the answer to number 3. Uh, 4 and 5 get a point. There were 5 colors, 3 transmission choices, 4 interiors, 2 engines. So that's how we got 120 different variations. Number 4 has Taylor on a shopping spree. She buys 6 tops, 3 shorts, and 4 pairs of sandals. How many different outfits could she create from her new purchases? Every group can have a point. 6 times 3 times 4, which is 72. Number 5 is more this medium to hard. That's more like what your chapter 3 test looked like. We have an ATM code, and we've got to use 6 letters of the alphabet, and we can't have any repeats. 5 gets a point. How'd she know that? Well, she's done quite a few of these. So you know she had 6 options for the first letter. But since there are no letters repeated, after I used 1 letter, it's out. So for instance, it said there were 6 letters, so A, B, C, D, E, F. Let's say her first letter she chose was A. Well, now A is out. She only has 5 options for that second slot. Let's say she chooses B because she stinks and she's going directly in order. Well, then she only has 4 options for that third slot. Let's say she chooses C because she wants her password to stink. She only has 3 options for that last slot. So it's 6 times 5 times 4 times 3, which is how she got 360. No letter repeated. Okay, so the only thing I would add, besides that, counting principles are really pretty nice. The key phrase here was no letter repeated. That's why we counted down. If we change this problem, let's cross that out and say that letters are repeated, we would get a different answer because we would have 6 options for the first, 6 options for the second, 6 options for the third, 6 options for the fourth, and so it ended up being 6 times 6 times 6 times 6. So it depends. Did it say letters are repeated or no letters repeated? That does change the problem. I give you that. But if you chose A, my gosh, that's the worst passcode I think I've heard of. I think that's worse than ABCD. I don't know. Or 1, 2, 3, 4. Or 1, 2, 3, 4. It's very predictable. Okay, are there any questions about the counting principle class? Okay, you're normally pretty good at this. The issue is that we started mixing this in with other stuff lately, and you've been like, I don't know what to use when. And that's totally understandable. So, and kind of slightly intentional on my part, it's more fun that way. So in the next slide, we get to permutations. Okay, so what on earth is the difference between what we were just doing, the counting principle, and a problem that's called a permutation? What's the difference?
Order matters.
Well, one thing is that order matters. I am going to make that note. But I'm also going to put a word above that, and that word is selection. In the counting principle, we're just multiplying all the options. With permutations and combinations, we might have the 25 people in this room, and we're just selecting the 4 people at table 2. So if we're going to select, like from this large group, I'm only selecting the 4 people at table 2, that's going to end up being a permutation or a combination. And the difference between a permutation and a combination has to deal with whether or not order matters. Does the order matter? What do you mean by order matters, Ms. Compton? Okay, if I say everyone at table 2 gets to leave early, then Misha is not going to be mad at Grant. Grant's not going to be mad at Caitlin. No one's the winner, right? They're all getting to leave early. Like, table 2 wins, yeah, but there's no clear one person out of there. What if I said Grant's in first place, Caitlin's in second, Misha's in third? Then doesn't that make a difference? And then Grant's the clear winner. So did the order matter then for whatever he's getting? And then yes. So what I think of to remember with order matters, the word permutation starts with a P. And so does the word picky. When we start being picky, because it mattered that Grant got to hit the door first, because apparently if the person that hit the door first got a prize or something, that's when we need a permutation. I mentioned this last week with your coloring page. I didn't really explain it, so it's definitely understandable if you don't understand the exclamation point. Okay, so in math class, we do have exclamation points. And no, we're not saying like we're super excited at 15. 15 exclamation point, yay, 15. No, it actually stands for multiply all the way down. So like on number 6, the 15 factorial, that's what the exclamation point is called. It's called a factorial. It means multiply all the way down to 15, 14, 13, 12, all the way to 1. It's just our way of noting that. So like 6 factorial means 6, 5, 4, 3, 2, 1. Okay, so with the permutation formula, it looks complicated because they use N's and R's, and I know I don't like it when they start putting too many letters in math class. So my note to myself about the formula is that in the numerator, we always put the total number, total exclamation point. And in the denominator, we always put the total minus the ones I want. Total minus, I'm going to put select. And that's a better way to put that. Okay, so like in number 6, it says the baseball team has 15 players. So the total is 15. So that's why there's a 15 in the numerator. It says how many 9-player orders are possible. So we're wanting 9. So in the denominator, I have 15 minus 9. Well, you know 15 minus 9 is 6. So really in the denominator, I have 6 factorial. When you end up multiplying it all the way out, because you do 15 all the way down to 1 and 6 all the way down to 1, notice like the 6's could cancel out, the 5's could cancel out, 4's, 3's, 2's, 1's, and you can end up just having, like that's not a big thing, just having to type in 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7, which I get is still a really big thing. Now, let me do a couple more, and then I'll show you how to use the handy-dandy calculator in case you wanted to. I normally don't. I'm a good math student. I like to show my work. It's not that deep. I can handle it. But I like to check myself with the calculator, so I'll definitely show you how to. And if you want to rely on it and it be your friend, I totally understand. Okay, so number 7 says that there are 7 people in this swim meet. So that's why there's a 7 in the numerator. If there are no ties, how many ways to the gold, silver, and bronze medals? Well, that means we have 3 medals possible. So in the denominator, I'm selecting 3. So 7 minus 3, and I get 4. Are there any questions about how I got the denominator of 4? Okay, well, if I want to, I can still multiply this out. Whoop, missed something. So I did 7 all the way down to 1, and then 4, 3, 2, 1, and then, hey, that fun cross-canceling happens again. 4s go, 3s go, 2s go, 1s go, and yes, Grant, you can have your point. You do get 210. Okay, are there any questions about number 8? Number 7. I can read today. Number 7. We're going to skip number 8 for a second, and let's go to number 9. Now, number 9 is a bit of a debate, because honestly, he's a disc jockey, and he's going to choose 3 songs for the last 2 minutes of the evening show. There are 9 songs they can choose from. How many ways can he choose and arrange to play 3 of those 9 songs? Does the order really matter? I would say no, and I'm not sure I would have put this in the permutation flap. But someone last period argued like maybe he's going to lose all his audience on that first song if he doesn't play the right song. So maybe the order does matter with music selection. Maybe so. How many options were there total? You can have a point. What should I put in the denominator? You can have another point. And so really I have 9 and 6. So I can do 9 times 8 times 7 times 6. And you can keep going if you want to, but at this point I start getting lazy on you. And honestly, I realize 6, 5, 4, 3, 2, 1 is going to happen in the top and in the bottom. So I just cancel out the 2 6 factorials. So I only have to do 9 times 8 times 7. You can have another point. Okay, and then we'll skip the zombie one for a second. Let's go down to number 11. If you've not seen the movie My Cousin Vinny, it's a good one. Strange, but good. So in this movie, My Cousin Vinny, Vinny is the cousin of, I think, Billy. But Billy and Stan get arrested for a crime they didn't commit. And Vinny pretends to be a lawyer, and he tries to get them off. And he's got a Yankee accent, and he's in like down south Alabama, and they talk even more redneck than we thought was possible, and it's an interesting movie though nonetheless. It is good. Okay, so there are so many people trying out for the roles, and there are 3 main roles. So what should I put in the numerator? And what should I put in the denominator? Okay, why does the order matter when we're selecting roles in a play? Yeah, Vinny has way more lines. You can have a point, Claire. Way more lines than Stan and Billy. Like, it's called My Cousin Vinny because he is the star. So it's a difference of are you the star or are you not. So 8, 7, 6, 5. I already understood there was going to be a 5 in the denominator, and I can cross cancel. If Royale enjoyed writing it all the way out and then canceling it out, no one's going to get on with him or stop him. Okay, what do you get as your final answer? Every group can have a point. Okay, and there are 2 problems that I've skipped, and no, we're not skipping them entirely. We're going to come back to them right now. Let's talk about why these 2 are special. Okay, look at number 8, and then look at number 10. They both allow for repetition. So I'm going to put a star by 8 and 10, and I'm probably going to put repetition, repeats, something like that. We got to consider the repeats. Okay, I'm going to start off with number 10's way easier, but I'm going to start off with explaining number 8 because it's easiest to explain number 8. Okay, so I know there's a fancy formula up at the top. No, you don't need to know the fancy formula. I can explain it to you in English as follows. Let's say I give you the word dad. How many other ways can you rearrange that 3-letter combo? You could do add. It doesn't have to be a word, by the way. Okay, DDA. Now what? Why is that in? Because of the D's, the double D's. Yes, it is a palindrome, like you're right. Because of the dad forwards and backwards. But anyway, because of the repeated D's. In the same way in the word Mississippi, if we rearrange the letters, and all Lauren actually does is make the two P's swap spots, did she technically rearrange the word Mississippi? No. If we rearrange the word Mississippi, and I make that front I and that back I swap places, did I technically rearrange the word Mississippi? No. So if there's a lot of repetition, we've got to count for that. If you count up all the letters in the word Mississippi, there are 11 letters, so that's why there's an 11 in the numerator. In the denominator, the first 4 is for 1, 2, 3, 4, those 4 S's. The second 4 is for the 1, 2, 3, 4 I's. And then the 2 is for those 2 P's. I like making people do words. There are some states that are especially fun, like Massachusetts or Alabama's not bad. Georgia's boring. No, super boring in Florida because there are no repeats. Banana is a fun one. Okay, so anyway, when you work it all out, you're like 11, 10, 9, 8, 7, 6, 5, 4. And then the denominator, yeah, we have that first 4 factorial, but we still have that second 4 factorial, which is 4, 3, 2, 1. And heck, we still have the 2 factorial, which is 2, 1. So I know these two cancel out. And then is where you and I might be different. I'm a math nerd. Yes, dear. You're going to want to do what I'm going to do. I already know this. If you like math, master things, you're like, oh, okay, well, 3 times 2 is 6. 6 is out. 4 times 2 is 8. 8's out. Now in the denominator, all I have is 1s. In the numerator, I just have to do 11 times 10 times 9 times 7 times 5, and I'll know the answer. I'm going to help you. Who said what? Give me half a second. Someone know the number? It's a big one. You can have another point line. Okay. If you said what and didn't want to do that, 1, you can always, no one's taking this away from you. Let me see if I can show both at once. You can always type it out in your calculator. 11 times 10 times 9 times 8, and keep on going all the way out. Do the denominator all the way out. No one's going to stop you. What's it going to take? 30 seconds? Please. Or, if you're still too lazy for that one, your calculator can do all of this. I've just not showed you the buttons before. Here's your one chance to see all the buttons. If your calculator has the word math on it, if you press math, literally my calculator has a button that says math. I press math. I see some options at the top. You and I are doing probability. PRB is probability. I see option 2 is permutations directly. You can type the problem directly in and it'll solve it. 3 is combinations. Directly type it in and it'll solve it. 4 is the exclamation point, the factorial. So I could potentially 11 math, miss something. 11 math, I can do this. 11 math, probability, factorial, divided by 4 math, factorial, 4 math, factorial, 2 math, factorial. I could type it directly in my calculator. It works. That's if you want to do that. The hardest way would be to actually type it out 11 times 10 times 9 times 7 times 6 times 5 times 4, 3 times 2 times 1. You could type it all the way out, like there's my numerator. My denominator was 4321. 4321. 21. And then I could say that number divided by the other number. I mean, there are like 1,000 ways I can get there. I like cross canceling, but you can like whatever you like to make it happen. Okay, any questions about that one? I swear the zombie one's a lot easier. How many zombie options are there? Why? But the order we're going to say matters because it's on the permutation page. Does it actually matter in real life? No. Maybe we're going to shoot the first one that comes to us. Again, I'm literally doing it as permutation because it's on the permutation page. Otherwise, I'm totally with you, Lauren. So how many repeats were there? None of those zombies match.
2.
So I've got 432 factorial over 2 factorial. I end up getting just 12. Otherwise, I agree with you, Lauren. People debate what problems should be. If they don't say something specific about first, second, third, I agree. Why is it necessarily a permutation? Okay, any major questions about this? Okay, so basically, permutation, the order matters. That's when we're going to use this formula. Combination, flip to the next slide. It's our last page. With a combination, it's still different from the counting principle because we're selecting something. We're making a selection. We're selecting, like, remember we had 8 jurors and we were selecting 3 of them? But the order doesn't matter. Again, if I told table 2 they get to leave early, it doesn't matter. Like, everybody at table 2 would be equally important. Okay, so the easiest way to explain this one is we still put the total in the numerator. But in the denominator, I like to think of it, and this combinations drive me crazy, because you would think combinations, we're not being picky. Why do they have a more complicated formula? Well, it's because we're not being picky. So we gotta allow, like, Grant, Misha, Caitlin, Misha, Grant, Caitlin, Caitlin, Misha, Grant. Like, we gotta allow all the options of, like, all different ways Grant can be in first place. Well, he's not in first place. Grant's name can be said first. So we still do the total in the numerator. In the denominator, you do what you want. Is that what I said? That was the best way I explained it yet. Yeah. You want to do the ones you want, like I want 3 people, and the ones you don't want. So I was thinking back on, like, the jurors, because that's, my mind goes to your textbook, to what we were doing recently. So, like, when we were doing the juror problem, there were 8 total people. We were selecting 3 of them, so that meant there were 5 people left. Okay, what is 3 plus 5? Okay, notice that every single time, you're going to know you did a combination correctly if the denominator, the 2 numbers add up to that numerator. 3 plus 5 is 8. On our next example, 4 plus 6 is 10. Always the 2 in the denominator should add up to that numerator. Always. Well, it's because I want these, which means I don't want those. I mean, we can't be a girl and saying, these I'm not sure about. Like, you either want them or you don't. Don't want. Okay, so number 12 says that there is a group of 12 students, no, 10 students, I can read, and we're selecting 4 of them to go to something. Be selected from a group to take part in a class in cell biology. Good for them. So we had 10 options, we're selecting 4 of them, so that means there were 6 we didn't want, which is how we got 10, 9, 8, 7. The 6 factorials cancel out. And then from here, Sarah can put it straight in her calculator. Or if Sarah's like me, maybe she says 4 times 2 is 8. So then she just has to do like 630 in the numerator divided by 3. You end up getting 210. Any questions on number 12? We're selecting 7 cards from a standard deck of 52, so that means there are 45 we aren't selecting. I promise you I'm not going to make you work this one all the way out, but if we did, the pink would be in my numerator. My denominator would be 7, 6, 5, 4, 3, 2, 45 factorial, and the 45 factorials would cancel out. Does it still end up being a giant number pain in the rear? Yes, it does. So I'm going to tell you the answer on that one. Number 13, the answer is 133,784,560. I promise you the ones on the test are not this ridiculous. In fact, you know me. Huh? Yes, dear. You know me, the ones on the test are more like number 14. Let's look at 14. Yay, ice cream. Dairy Queen has 12 flavors. So I'm going to put 12 in the numerator. What do I have in the denominator? You can have a point. 4 and 5 can. So we got 12, 11, 10, 9 factorial, 3, 2, 9 factorial. And then I know the 9s cancel out. And then, again, Brittany can straight from here type it in her calculator. I'm just trying to be super mathy today. Forgive me. I know that 3 times 2 is 6, and 6 goes in 12 2 times. So I can do some more cross-canceling if I want to. Do you have to? Heck no. Could you type in your calculator 12, 11, 10 divided by 3, 2? Yes, you could. Okay, are there any questions about 14? Someone besides table 4, can you help me set up 15? The answer on 14 is yes. I thought it was 220. Okay, I thought you said 210. Yeah, it's 220. Sorry, dear. You can have, this is why you can't answer next. You get another point for fixing that. Okay, number 15. Can someone besides Lauren and her table help me set up 15? Huh? What do I put in the numerator? What do I put in the denominator? No, Brittany, not you. And does that add up to 25? 1 and 5 get a point. And if we worked it all the way out, and I'm not going to make you, the answer to number 15 is 53,130. Okay, number 16. Someone else help me set it up. Two gets the point. And if you were to actually work that one out, it ends up being 24,310. Again, the ones on the test tend to be smaller numbers than this. So there are 10 in the league. Number 17 is probably one of the more challenging ones. You actually have to think, what should I put in the denominator? No, because you got to play somebody. So, but count yourself. Don't do 9 and 1 because you got to count. Like you play somebody else, so you are always in a. Yeah, it's got to be 2 and 8 because I'm in a pair. Me and like you were playing, and then there were still 8 other teams I got to play. Huh? Do what? Yeah, you. I mean, you won't fall all the way down, but the reason it's a 2 is because 2 teams have to play. There's a stable in the very top one. And then 18, how many 3 topping pizzas can we order? Giving the menu option on the right. So how many options are there? Number 18, how many pizza options are there? According to that toppings list. Yeah. No, we haven't allowed combos. We're just saying just onion, just green peppers. If we start allowing combos, it's a way bigger number than 12. How many are we selecting? And then there'd be 9 left over that we're not using. So that's how we get our answer, which is, again, 220. We had one earlier that was the same, funnily enough. Which one? Oh, bless you. You can have another point for that. 17 is 45. Because it ended up being 10, 9, 8 factorial over 2 times 8 factorial. So it was 180, no, it was 90 divided by 2, which is 45. Good job, Caitlin. Thank you. I love I missed that. Okay, that's all the words I've got to say.
Can you go back over 17?
Yes, 17.
Yeah.
Okay, so there are 10 teams, right? 2 of them have to play. Like me and somebody else has to play. Now I still need to play the other 8 teams, yes, but like I'm paired with somebody to play a game. It can't just be just, if you were thinking 1 and 9, well, are you technically playing a game if you're by yourself? So that's why I have to be paired. I'm not a baseball person, player, so it's definitely not women. That is not me. You want to stable a tile, Grant? You must say thank you, Grant.